That's my friend Bill Deese from Louisiana Tech. Gosh, you got a lot of stuff written down there.
This is my email, man, and I've been out there dodging traffic on the information highway.
Hitting a pothole.
Hitting potholes.
Let's explain to people what we're talking about. Several weeks ago, we did another one of our
Science Puzzlers.
Science Puzzlers.
And it had to do with siphons.
That's right.
Okay, and we had this exact siphon on the show.
Now, we've been having a lot of entries from like junior high and high school kids.
Right.
And now you show us one, and the email is from whom?
The email is from NASA.
From NASA. Now, that's the National Aeronautics and Space Administration.
It's from a man named Flint Wild, and he is at the Marshall Space Flight Center.
That's in Houston.
And he's connected with NASA Space...
Is that in Huntsville?
I think it's in Huntsville.
Okay.
I'm not sure. I didn't get the... all I got was his email address, okay? And I contacted him through Legene Thomas at Louisiana Tech, put me in touch with him. And he says, your question is quite interesting. Unfortunately, we at SpaceLink do not have a definitive answer.
Well, how good? The junior high kids, if you didn't get it, junior high kids.
The question was, would this siphon with water, using this hose, work on the surface of the moon?
Now, we did a little siphon work with it last time.
Right, we have the tube filled with water, and of course the tube goes below the water on both sides. And if you raise this side up, the water will siphon in that direction, etc.
Vice versa. Okay. Until they're equalized.
Right.
Okay.
And so,
the question was, will it work on the moon where the gravity is about 1
Okay,
6?
there are many things to consider. Okay. And our friend from NASA helps us remember these. The gravity on the moon is about 1/6 what it is on Earth.
And I knew that.
Okay. And so we do have gravity, even though it's less. All right, now...
The reason I'd like to go to the moon, I wouldn't weigh but about 20 pounds.
What makes this hard to answer is there is no atmosphere on the moon.
Right.
Okay? So in other words, we'll be trying to have a siphon operate in a vacuum. Okay? Plus, what a lot of people forget to consider is the temperature on the surface of the moon. Now, if you're in the shade or on the dark side of the moon, if you've ever been to the dark side, it's cold. It's way below freezing.
So this would freeze.
And this would freeze. And in the sunny side of the moon, it's not, the temperature is not above the freezing point of water, I don't think, but it's very high, okay? Plus, there's going to be a very low pressure, a zero pressure above the water, so the water is going to immediately begin to boil, okay? Now,
so the moon wasn't exactly the best place to talk about doing this.
My answer is that if you, in some way, immediately expose this on the surface of the moon, the water will immediately begin to boil, fill this tube with water vapor, and the siphon will not work.
Okay.
Okay. Now, the popular belief is that you have to have an external pressure on the high side to keep filling this tube with water.
Okay.
Okay. Now, I found in textbooks where you've got both things said. That you can, for instance, this is not a textbook, but Gerald Walker, who wrote this book, The Flying Circus of Physics.
Which is a big bestseller.
A big bestseller.
This book is sold in the dozens.
Now, this is the best one, the new edition, because it has answers. Because this is a book full of puzzles.
Like this.
And he says, in his answer to a question about siphons, contrary to much popular belief, the fluid is not pushed over the siphon by air pressure, as is disproven by the fact that siphons can operate in a vacuum.
Can operate.
Now, this fellow is a professor of physics at Cleveland State University.
Oh, Cleveland State. Who ever heard of Cleveland State?
The physicists at Louisiana Tech University disagree.
There's a school.
My good friend Paul Stevenson says, I can quote him, a siphon will not work, a water siphon will not work in the presence of under a vacuum. Okay. My good friend Bobby Hamburg, that's right, Bobby Hamburg at Louisiana Tech, he'd set up a bell jar and we pumped down on a vacuum, and he had vacuum oil in there, and he thought it was going to work, but we discovered we had a leak in our vacuum system. So
no definitive answer
there. But based on my colleagues in the physics department, and my own theory is that the water will begin to boil and it won't operate. I don't think it'll work on the surface of the moon. Now, Clint here from NASA points out something. He says, if on the surface of the moon, how will you start the siphon? Now, an astronaut can't suck on the hose because he's got a helmet on, right?
Not unless he wants to create a real health problem for
Plus, if there's no atmosphere, you can't draw a liquid up a straw anyway. Now, he says you're going to have to start it with a pump, and if you have a pump, what do you need a siphon for anyway? Those guys at NASA.
Excellent.
Those guys
people
at NASA
are a little sarcastic, aren't they?
But we have an entry here from Chris Brown at Ruston High School.
Okay.
Okay. And this is from Amy Talley's class. He says, yes, it will work because gravity is going to be pulling more on the low side, and that's going to pull.
Let's give Chris the prize.
We're going to give Chris the prize.
Chris,
the siphon hose from Backus True Value Hardware in Ruston, and I'll deliver that to Ruston High School today.
Chris, congratulations. This starts you on a life of crime. You can start siphoning gasoline out in the parking lot at Ruston High School. Bill, nice to have you here today. You've confused everyone, including the people.
No one knows the answer now, I'm sure.
Including the people at NASA are a little worried about it. There will be $1 billion federal appropriation to try to solve this problem, so you've contributed to the national deficit. Keep up the good work. We're going to take a break. We'll be right back.